Hello, welcome all to a new session on Introduction to STM32 microcontrollers and development boards. And today, at the end of this session, so you'll be able to know about different ARM Cortex M based development boards. And the topics I will be covering today are about development boards and especially on Cortex M3 based development boards. And we have few development boards on Nucleo ST microelectronics, and I'll be explaining STM32 Nucleo 64 series in detail. The last session we have seen about the Cortex M3. What is Cortex M3 microcontrollers and its different features, and we have seen that as part of this Cortex M3, along with the ARM7 V7 core, M core, we have few peripherals are embedded in it, like NVIC and few MPUs, and similarly the bus architectures, etc. So, but when it comes to a microcontroller, it is something like the core plus additional peripherals, and it will be like different vendors, right? So different vendors will be manufacturing the controllers. So as part of this controller, there will be a ARM Cortex M3 based core will be there, and supported there will be n number of peripherals will be there additionally. And what is this development boards? So generally, in embedded scenarios, when you want to develop something, a kind of concept if you want to implement. So basically, what people will be initially implementing things, or maybe they'll be developing the prototype on a development boards. And this development boards are something like it's a PCB boards with the main microcontroller, and there will be additional few peripherals like connectors, etc. will be terminated over there, and then few passive component drivers, etc. will be there on the board. And development boards are meant for system designers to become acquainted with programming a processor on board, and also to develop and test the project effectively and efficiently. So if you want to try out some of your prototype, so we'll be seeing like before making your own custom board, so we'll be using the development board from various vendors. So coming to the Cortex M3, there are many vendors are available, like board vendors like Analog Devices, we have NXP Semiconductors, Realtek, ST Microelectronics, and Toshiba. There are many companies are there. So you can select the target vendors, and then all these vendors manufactures various development boards in the Cortex series. So in this course, we will be targeting basically with the Cortex M series, and especially on M3 series. And on the ARM official website, if you visit, you can see the development board support and from various vendors. And then apart from that, you can also identify on development boards what are the additional drivers are actually enabled. So you can select your development boards depending upon your requirements. So these are few development boards which I plotted here on the image, like a Nucleo series, and it is from ST Microelectronics. There are few from NXP Semiconductors, Silicon Labs, so are listed over here. And now ST Microelectronics are something like which is a widely available microcontrollers, or it's a popular vendor, and there are so many series are available. If you come to the ST Microelectronics, because as part of our course, so we'll be using the development boards from ST Microelectronics. And ST is developing, there are various type of controllers from starting with various target applications. Suppose the target applications which they are kept is like high performance microcontrollers, and mainstream microcontrollers, and ultra low power microcontrollers, and similarly the controllers used for wireless applications, which they call it as wireless MCUs. Okay, so these are some series of family like MCU and MPU families. And under the each series they have targeting with the high performance. Similarly for mainstream there are many series of microcontrollers are available, and few actually I'll name it. For example, if you go for a high performance microcontrollers, there are STM32 F2 series are available, F4 series, and recently they are also released with the X7 series. And all these series are available with microcontroller targeting from 180 megahertz Cortex M3, which is at F2, and similarly 180 megahertz Cortex M4 for F4 series, and similarly for 216 megahertz Cortex M7 at F7, and similarly 240 megahertz Cortex M3 and 550 megahertz Cortex M7. That combination we sometimes call it as H7, high performance. And similarly there are MPUs are available, which they released a few MPU series with MP1 series at with a running frequency of 800 megahertz Cortex A and 209 megahertz Cortex M4. It's a kind of big little combination. There is a MPU also released by our ST Microelectronics. So similarly we have mainstream MCUs are there. So if you are looking for mainstream applications, embedded application, there are the series with F0, G0, F1, G4, F3. So all these series of microcontrollers are available from ST Microelectronics, and which generally operates between 48 megahertz to something around 170 megahertz. And we have M0 and M3 and M4 controllers are available in the mainstream. So suppose if your target application is for ultra low power, like if you are aiming for this ultra low power applications, so there are L series are available. So basically this L series start with L0, L1, L4, L4 plus, L5 and U5. So these all series are generally offering ultra low power applications. So what will happen among your applications, if you are targeting with the battery operated devices, so if you are prototyping that, so you can go with all these kind of microcontroller series. So generally the ultra low power series are operating with a low frequency from starting from 32 megahertz to up to 160 megahertz, and the 32 megahertz, which is generally with M0 and M0 plus and M3 and M4 series controllers are available. So the latest series like M33 is also available in the ultra low power. So depending upon the the target applications, so people can select the controllers. And similarly another area of application of this embedded system is wireless sensor networks as well as IoT. Suppose you are targeting for something on the LoRa, and similarly for Wi-Fi, and similarly for Bluetooth, etc. kind of applications. See the microcontroller series with STM32 WL, so and WB. So these two series are operating at M4, M3, M4 and M0 plus series, and which generally with the 32 and 48 megahertz, which will give you an option provision for running with various wireless end node kind of applications or gateway applications, which you can develop using these kind of series. So this is a a generic portfolio which I have given of list of microcontroller from STM32, and basically this series which available with the cost, and similarly there are range, and similarly ultra low power. So basically L series are really good, as I was mentioning. But in all these product lines, whatever we are seeing, so you will be getting peripherals such as ADCs, USBs, and various amount of flash. Depending upon your requirement, there are options to select. Okay, so the internal flash options, you can select it, and which may vary from sometimes 32K, 512K, 128K, etc. And then in certain controllers, you will be also getting option for securing your application, like AES support if it's required. So there are few product lines are available which you can use the controller with AES support. Okay. Now these are basically if you target with STM on Cortex M series, suppose if you are selecting. So there are different types of development boards are available. So sometimes we call it as Nucleo boards, and similarly there are discovery boards are there, and evaluation kits are there. So these are the main three boards or maybe development boards which is manufactured by STM. Out of that, this Nucleo are something we call it as flexible prototyping. So if you are targeting for like a kind of an existing third party expansion boards, if you want to interface, so then it will be easy for you for selecting the Nucleo series. And the if you are prototyping for certain key features, okay, something on like your power electronics or maybe for some motor control, well, some key features you are targeting, then you can select with the evaluation or sorry so the discovery kits are basically targeting for prototyping a typical feature. Now for certain applications, suppose if you want for the complete features need to be evaluated as part of your development, in such cases you can go with a evaluation board. So the flexible prototyping, we have the STM32 Nucleo, and key feature based prototyping you can go with the discovery kits. And similarly, if you want the full features, if you want to access, so you can go with the evaluation boards. So these are the three types of boards available from Cortex M series based boards available from ST Microelectronics. Now what happens, suppose you have selected a STM32 Nucleo board, but this Nucleo board comes with a microcontroller and enabled with few peripherals. So suppose if you want to do more experiments, like suppose if you want to rotate a motor, or maybe you need a motor drive is required, or suppose if you want to add a temperature sensor or any other kind of sensors, or suppose if you want to use a audio interfacing, or you want a third party wireless interfacing, etc., like functionality based. So for that purpose, so the Nucleo boards are provided with a connector we generally call it as an expansion connectors. So STM32 Nucleo expansion connectors. These connectors are some are based on your Arduino compatibility. You have like the Arduino boards, no, the general Arduino boards. So there is a Arduino compatibility is there. The pin connectors are there. So you can piggyback this, and then you can develop your application. That is actually one of the feature of this Nucleo boards. Now apart from that, the boards which I mentioned, like Nucleo and discovery and evaluation, which are from STM, but there are third party vendors are also developing their development boards, or maybe we call it as custom boards. So these custom boards comes with STM microcontrollers, but there will be peripherals will be different, and some of the sensors will be added on this one. And again, people can make the board yourself, because the microcontroller manufacturer provide you all the details related, not only the STM, almost all vendors, they will be providing the details, the controller details, so that you can develop your own custom development boards. And now coming to the STM32 Nucleo, which we will be targeting as part of our course. And the one of the major advantages, the flexible prototyping. So you can see here itself on the board, there's a two sections you can see. There is a this is a one part and this another part. This top part is generally used for debugging kind of thing. So you don't need to buy any additional debugger. That is one of the biggest advantage of this development boards. So in olden days, actually the debuggers are coming separately. So you need to purchase the debugger, you need to purchase the development boards. So now in the Nucleo case, so the debugger is part of it, so that so your prototyping will be very easy. And I was mentioned about there's some connectors, right? You can see the connector. There are two type of connectors are there. So the connectors which is mentioned with D0, D1, D2, D3, and we have A0, A1, A2, A3. So these inner connectors are something like Arduino expansion connectors. So unlimited expansion capabilities are available. So and you can use this one and simplify simply show the whole STM32 portfolio to the communities. For example, if you want to prototype with the Arduino, that is also a kind of solution we can use it, software solution, because Arduino also nowadays supports the board support for STM32. And similarly, for ARM, we have the embed compiler support is enabled for STM32. So wherever actually embed support is required, so you need to see the board with the embed support. So generally that will be mentioned, a logo will be mentioned on top of your board, so that you will be able to identify that okay, this board is having embed support. So embed is a kind of an online a kind of a platform, or maybe software development platform from the ARM. And coming to the Nucleo, there are different choices are available for the developers. So there are very small nano compatible boards are there. We sometimes called as Nucleo 32, means it's a 32 pin MCU. So you'll be having only minimal peripherals will be there. So it is something equal to your Nano, Arduino Nano. That's a comparison we have kept. And then there are development boards which we available with 64 pin. So that many number of pins will be available on your form factor will be available, and which is having the UNO connector or maybe ST Morpho connectors will be available, so that your expansion boards for adding the third party actuators and sensors, so you can use that one. And there are few boards are coming with high-end boards with capability of Ethernet, USBs, etc. So we call that as Nucleo 144. So Nucleo 144 is something like with 144 pin MCU, and more peripherals will be enabled. Apart from that, you will be having connectors related to USB, and similarly Ethernet connectors will be there on board. And the basic things related to this Nucleo, there are many Nucleo series which we have seen, like 32 series, 64 series, 144 series. So there are many series are available, and the graph plotted here is something like it is the internal flash, because basically if you are going with a very small application and very ultra low power application, you may not your code size will be very minimal, so you don't have any large memory, will be minimal in this scenario. So the chart shows that flash varies between 16K to something around 2 mega. Okay, so this is the 2 MB internal flash will be available. So again, you are having options between 32, 64 as well as 144 depending upon your requirement. And requirements something like performance requirement, sometimes the peripheral requirement, and the ultra low power means again the power requirement, and also the price. So there is a option, broad range of options are available in the Nucleo 32. And I was mentioning about the shields. These are the way people generally used to connect the shields. So you can either directly use the expansion connectors related to various sensors, temperature, humidity, accelerometer, etc., gyro connectors, or it may be something on the motor drive, or it may be something related to creating a battery support, so that battery operated device kind of things, if you want to prototype it, that is possible, or connectivity as I was mentioning related to Bluetooth. And then very important thing is how to whenever you are connecting all these kind of sensors, so the STM also provides rich set of libraries, software libraries. Sometimes we call it as a cube. STM cube is one of the solutions for creating various applications for STM based microcontrollers. And not only the cube ID, there will be many ID supports are available. We'll be talking on the ID like IAR workbench and ARM based various IDs which already you have started, like Keel kind of thing. And these are a list of expansion board which is provided by ST. Not only ST, there are third party connectors also, sorry, the expansion boards are also available to you for various application or prototyping. Something related to analog sensors, digital sensors, related to your motion and environmental sensors, and something related to proximity, and you have the digital microphone, and analog microphone. So all these sensor packages, or we call it as shields, are available. And related to communication, there are wide range of communication solutions are available, starting with NFC, power line communication, or it is something related to your GPS based thing, or you have the USB options, and similarly the additional safety and security modules. And there are, for motor driving application, for various targeted motors, we have the stepper motor, and you have DC motor, VLDCs. So all these kind of motor drives are available as a shields. And similarly for translation logics, so there are graphics, LED drivers, and similarly for the sound sensing modules, etc., are available as a expansion connector. So you can directly piggyback those connectors on the top of your Nucleo development boards, and you can start prototyping your applications. So apart from STM, so you can develop the third-party expansion boards. So we will be experiencing that third-party expansion board, because Neelit has developed a few expansion board for Nucleo-based applications. So we will be you will be doing the hands-on in the next week onwards. Few of the applications will be running on our expansion board, which we are connecting on top of the STM development board. Okay. And expansion, third-party expansion board here, as we are showing like something on communication, especially for sub-1 GHz communication such as LoRaWAN and power line communication, or even including your the automotive Ethernet, Profibus, or Modbus. So all these kind of industrial communication application, there are expansion boards are available in the market. Now coming to Discovery Kit, the difference is like it is specifically for some target like graphical applications, or it is something on cloud computing application, or if it's on Sigfox. So there are standard development boards or discovery kits are available, so that these features will be already embedded on your development board. You don't need to add any third-party expansion boards on your development board. So that typical feature will be enabled on it. Okay. So that is the discovery kit series available from the the STM. And coming to evaluation board, which is a costly board, and most of the features will be embedded on it, so that displays, communications, and drivers, all these things will be activated on this board. So if you are performing a kind of prototyping, a kind of a product, so with all the features suppose you are targeting, so then you can directly buy the evaluation board and you can start working on it. So these are few series of evaluation board from STM. Now coming to software development, suppose you have a series of development boards. So development boards are something like, you can see there will be a microcontroller and of STM32 M series or A series or whatever it is. Now we are targeting on M series. So along with that, the necessary drivers, right, and passive components will be added on to it, so that you will be getting connectors such as your USBs, you will be getting power connectors, and you will be having the displays, and there are few onboard buttons, sensors. All these things will be integrated on this development board. So you don't need to develop the your own PCB for this. So all the necessary components as well as peripherals will be enabled, so that you can directly start developing your application by using a suitable software environment. So suitable software environments are something like if you are working with a typical vendor, say for example from ST Microelectronics. ST Microelectronics provides Q packages, and similarly ARM, so which is the IP provider. So ARM is also providing you a kind of an IDE. We call that as ARM Keel solution. So the ARM Keel solution is something like it's a generic, so that if you are working with a STM based development boards, so you have the supported libraries are available. Suppose next day you are going with some other vendors, so you can also use same Keel IDE and you can develop application. But especially when you are going for a STM32 or maybe ST Microelectronics development boards, so then you will be getting an optimized packages from STM Cube IDE. So you can use the Cube IDE and you can start developing applications. So this is actually a vendor specific IDE, but ARM Keel is a a generic IDE so that you can utilize it. And not only the keel, again I am telling Arduino platforms also nowadays coming up with a certain certain library support for not all the STM series, but many of the STM series are having support with Arduino environment. So you can use the Arduino IDE also, and you can develop your applications. Now for high end, for example, if you are targeting with a Cortex application series, so the things will be different, because there we need to sometimes port an operating system such as Linux, or sometimes you need to work with the bootloaders such as U-boot, etc. So in that case you can use the build environment, and you can start developing various applications at the high end, at the operating system side. So that framework also is available in the community, so that we can utilize it. Now coming to, because our targeted development board is STM32F103. So this is the controller which we are using in the upcoming few days, so that you will be developing applications related to this STM32F103 base. So this F103, basically you can see there are many packages are available. As I told, under the F103 itself, there are many packages are available. There are 36 pin QFN connectors are there, and few are coming with the 48 pin QFN, and finally you can also get F series with the 144 pin BGA connectors. So depending upon your requirement, as well as your what are the peripherals need to be required for your applications, you can select the controllers. And again, the flexible flash memory size, you have starting with a 6K to something around 1 mega size RAM is available, as well as flash memory is also available with the similar package. So what you can do means you can select the microcontrollers. Now this is actually one of the development board which we are using. It is a STM32 Nucleo 64. So 64 stands for 64 pin microcontroller, and the microcontroller which we are using is STM32F103RB. So this is the series which we will be using for as part of our application, and its pinout is given. Like a detailed session on targeting on F103 will be taken separately, but as a development board which we are using, a Nucleo 64 development board will be using, and few peripherals are enabled. As I mentioned, IDs will be using Keel initially for this week for simulation, and the upcoming week we will be using the IDE which is related to Cube IDE, so that you will be exploring experiments at the Keel side as well as at the Cube IDE side. And then the debuggers are already enabled. As I mentioned, there is a onboard debugger is available, so we'll be using this debugger next time, and we'll be downloading our application and debugging scenarios. And few onboard LEDs etc. are available. A detailed view of the board will be given in the upcoming session. So this is all about the development boards which is used in the embedded side, and so we'll be having a few sessions on the development board, that is F103, and its detailing, port numbers, registers, peripheral details will be covering in the upcoming sessions. Thank you all.